Now let's talk about quadratic inequalities. So we looked at solving quadratic equations either by factoring, completing the square, or the quadratic formula. And what we found is that the solution set of the equation equals 0 is the same as finding the x-intercepts on the graph. So wherever we cross the x-axis, that's our solution set for the equal statement. Now, when my polynomial is pointed up like this, then above the x-axis, my y values are positive, and since the p is the y values, we're saying y is bigger than 0, that would be this interval where I'm above the x-axis. So that would be from x equals negative infinity up to x equals a, and again from x equals b to x equals positive infinity. When y values are below the x-axis, in between a and b. If it's upside down, then those two inequalities would be switched. If I have only one real solution, then one of these inequalities will be the empty set. If my graph only is above the x-axis, then the less than would be the empty set. If my graph is only below, then the bigger than would be the empty set. And then my solution to the bigger than 0 would be everything that's not 0. If I don't have any real solutions, if I have two imaginary solutions, two complex solutions, then I never cross the x-axis because there are no real solutions. So I'm either always above it, in which case this polynomial inequality is true everywhere, and the others are false, or I'm always below it, in which case this polynomial inequality is always true and the others are false. So to solve a quadratic inequality, we're going to solve the corresponding quadratic equation to get the zeros, then identify the intervals by plotting those zeros on a number line, and then test a value from each interval in the inequality to see if it's true or false. Let's look at this. X squared minus 11x plus 30 is greater than 0. So I can factor this. I'm looking at the factors of 30 that add to 11. That would be a minus 5 and a minus 6. So that means I have two zeros. X equals positive 5 because I'm solving x minus 5 equals 0. So I would add 5 to both sides. So at positive 5 and again at positive 6. So now, if I look at a number less than 5, anything less than 5, I could put negative 10,000 if I wanted to. But I'm going to pick 0 and plug it into the inequality. 0 minus 0 plus 30 would be positive. In between 5 and 6, I'll put 5.5. It's easier to plug in here. 5.5 minus 5 is positive. 5.5 minus 6 is negative. A positive times a negative is negative. And then bigger than 6, I'll pick 7. 7 minus 5 is positive. 7 minus 6 is positive. A positive times a positive is positive. So I'm positive here, and I want this to be bigger than 0. That would be positive. So my solution set would be negative infinity to 5, union 6 to infinity, where the positive signs are. Let's solve this guy. So the first thing that we need to do is, just like we had this one where it was set to 0, I need to do that over here first. So I'm going to subtract 3x from both sides, and I get 2x squared plus 5x less than or equal to 12. Now let's move the 12 over. And I get 2x squared plus 5x minus 12 is less than or equal to 0. Okay, so now if I look at the factors of 2, the factors of 2 are just 2 and 1. And if I look at the factors of 12, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. To quickly see if I can factor, I'm just going to take the factors over here and run them through the factors over here. So 2 times 1 is 2, 1 times 12, that won't go together because remembering I'm trying to subtract to 5. All right, so let's try this one. 4 and 6? Nope. How about 12 and 2? Nope. So I can rule out this set and this set. Let's try this one. 6 and 4? Nope. 3 and 8. Oh, that'll work. 3 and 8. So I want the 1 to multiply by the 3 and the 2 to multiply by the 4. So I know this breaks into 2x and x. And I know that this has got to break into 3 and 4. To get the 1 to multiply the 3, it would have to be positioned here for this inner multiplication. And the 2 to multiply the 4 has to go over here for the outer multiplication. Now I want to end up with a plus 5, so I need the 2 times 4 to be positive and this one to be negative. So that means x equals 3 halves or negative 4 are the zeros. So I'm plotting those on a number line. So negative 4 would be here, 3 halves here. I pick a number less than negative 4, like negative 5. Negative 10 minus 3 is negative. Negative 5 plus 4 is a negative 1. Negative times a negative is a positive. In between negative 4 and 3 halves, I'll pick 0. 0 minus 3 is negative. 0 plus 4 is positive, and negative times a positive is negative. And then bigger than 3 halves, I'll pick 10. 20 minus 3 is positive. 10 plus 4 is positive. A positive times a positive is positive. I want the negatives because this is less than 0. The negative is here. So I'm going to go from negative 4 to 3 halves. And because I have the equal to on this one, I'm not using parentheses. I'm going to use a bracket to include the 0.